Hello out there, trust you're doing well. Yeah, my name is Kuja Amos Maoko. So I'm here to take you FBA 110 and trust you're going to enjoy the class today. And our topic for today is set theory. Set theory. And as we go through this class, I would like you to give your full attention, and I can guarantee you're going to enjoy this class. Okay, so as mentioned earlier, I'm going to be your FBA tutor, and our topic today is set theory. My name is Peter Amos Maoklo. I'm an accounting student, 200 level, University of Lagos. Okay, by the end of this tutorial, you should be able to 1. Find a set of items. Identify the symbols used in set theory and also call them by name. 3. Types of sets. 4. Solve questions on set theory using Venn diagram. And the last one, solve 4-dimensional sets. Firstly, what is a set? If you played Monkey Post before, kind of sports game between 2, 3, 4, 5 players against the same number of people, you'll notice something that we usually call a team is set because it comprises of a group of people coming together to form a team. Now, we need to know that a set is a collection of objects, items, things, anything at all, most especially numbers. This object could be anything. It is usually represented in flower blazes or curly brackets. As you see it there, we have the opening curly brackets, and then we have 1, 3, 5, 7, and 9. All these numbers are separated by comma. We also have set of stationaries. Starts by what? Opening curly brackets. So we have stapler, pin, tippet, binder, so etc. And then end by what? The closing curly brackets. Each of the objects in the flower braces are separated by comma and is called an element or a member. So it means that if we go back to the example we have above, 1 is an element of set of numbers not greater than 10. 3 also is an element. 5 also is an element. 7 is an element. 9 is an element. Altogether they are called elements or members of set of odd numbers not greater than 10. Okay, so now we're going to talk about symbols used in set theory. As you can see it on the screen, I need to say this before we progress in this aspect. I would like you to take note of this. Here we have set C equals to 1, 2, 3, 4, and D equals to 3, 4, and 5. So we need to make use of set C and D for the explanation of all the symbols we have here. First, the first symbols we have here is the curly bracket. So it's used to make reference to set. So it means a collection of elements, as we have it there, 1, 2, 3, and 4 in the example column over there. So we have 1, 2, 3, and 4. They are both enclosed using curly brackets. So they are making reference to them as what? A set of items, a collection of elements. And the second one we have is A union B. And it's saying that A union B simply means that all the elements in A and B without repetition. All the elements you can see in A and B or both without repetition. Now, for example, if you say C union D, we'll have it there as 1, 2, 3, 4, and 5. You notice that we have 1, 2, 3, and 4 in set C, and we have 3, 4, and 5 in set D. But here we have almost everything we have in set C and D without repetition. Notice we have 3 and 4 in set C, and we also have 3 and 4 in set D. But still, they were not repeated in what? C union D. You only need to pick all the elements without repetition. Now, the third one we have there is what? A intersection B. So it means the elements that are common to A and B only. Now, checking the example we have above, C intersection D is equals to what? Is equals to 3 and 4. You can see 3 in set C, and you can also see 4 in set C. Likewise also 3 and 4 are found what? In set D. So intersection, what can be found in both sets C and D are 3 and 4. Those are the two elements. Now the next one we have here is what? Subset. So that's what? A subset B. So it means every element of A is in B. Every element of A is in B without B having any other more elements. Even if it's going to have more elements, it's going to be repetition of any of the elements in A. What I'm saying here is that if B is going to have any other element more than A, it's going to be repetition of elements already in A. So that's why we have 3, 4, 5. They are what? They are subset of B. Now, A proper subset B means that every element of A is in B, but B has more elements. 3 and 5, they are what? Proper subset of D, but still B has 4 as part of its element, but cannot be found in what? The first set we have here, 3 and 5. Okay, so we are still on symbols used in set theory. And now the next one we have here is what? A is not a subset. A is not a subset of B. So whenever you have the sign cancelled, it means what is not a member, it's not a subset of what? B. As you can see, it's there. 1 and 6 are not subset of what? C. And the next one we have there, it means what? A is a superset of B. So when you have the sign turning to the left, like C sign turning to what? Left. So it means superset. It means A has same element as B or more. So the more we're talking about here, it means you could have like more of the elements in A if B rather is having 1, 2, 3. A could have 1, 1, 2, 2, 3, 3. You notice it's almost the same thing, but just that A is having 2 1s, 2 2s, and 2 3s. So that's just the difference there. But talk about the next one. A is a proper superset of B. So it means that what? A has all the elements in B and more elements. So as you can see it on the screen there, we have the elements of A has what? 1, 2, 3, and 4. While the element of B has 1, 2, 3. You can see A has almost everything in what? B, and also has additional element, which is 4. Then we move to the next one. A is not what? A superset of B. So it means A is not a superset of B. Then now we move to the next one, which is A complement. So this could also be written as A prime with an apostrophe, or it could also be written as what? A prime. That's what? A with an apostrophe. It's called what? A complement. It means element not in A. It means element that can be found in the universal set, but cannot be found in A. So for example, assuming our universal set is 1, 2, 3, 4, 5, 6, and 7, and D equals to 3, 4, and 5. Now what are going to be the complement of D? So the complement of D, as you can see it here, is going to be 1, 2, 6, and 7, because those are the elements that cannot be found in D. They are the complement. They are the things that we added to D to make it a complete set of the universal set. Now the next one will have A minus B. A minus B simply means what? Difference. So it means the element in A but not in B. The element in A but not in B. That's what it simply means. Now for example, if we say we have 1, 2, 3, 4 minus 3, 4. So assuming 1, 2, 3, 4 stands for set C, while 3 and 4 stands for set E. Now C minus E is going to give us 1 and 2. The element in C but cannot be found in E. So those ones are what? 1 and 2, because 3 and 4 can be found in E. So we move to the next one. Small letter A is an element of capital letter A. So it means A is a member of set A. A is a member, small letter A is the member of what? Set A. Now, for example, as we have it under the example column, 3 is an element of what? Set A. As we have it here, assuming set A is 1, 2, 3, and 4, we can say 3 is an element of A. That's the set A. Now, we have another one there. B is not an element of A. When the sign that stands for, that represents element, is cancelled, it means not an element. We have a stroke on it. So it means B is not an element of A. Small letter B is not an element of A. Now, for example, 6 is not an element of sets. A set that contains that has a member of 1, 2, 3, and 4. Now, we have a zero sign that is cancelled. So it means not, like we call it empty set. A set that does not have anything. So it means there's nothing common. For example, a set that contains elements of 1 and 2 intersect a set that contains elements of 3 and 4. So that's what we call empty set. Nothing is common to both sets. We are still on symbols used in set theory. Now, the U sign, a capital letter U sign, represents universal set. It means a set that contains all the possible values in that context. Now, after that, we have P open brackets, A close brackets. So it means power set, power of A. So power set simply means that all the subsets of set A. For example, if you have to find the power of set A, which assuming set A it has element of 1 and 2. The possible values, the possible element that could be found in set A are 1, empty set, 1, 2, 1 and 2. So the way this one is calculated simply is, what you need to do, the formula is 2 raised to power n, and n represents the number of elements, the cardinality of elements in that particular set. Assuming set C it has 3 elements, the formula will then be 2 raised to power 3 because it has 3 elements. That will give us what? 8. It means we have different 8 subsets in that particular context. So we have the next one, A equals to B. So it means there is what? Equality between A and B. They have the same number of elements, equal elements. So we have A times B. That's what? Multiplication of elements in A and multiplication of elements in B. So the next one is what? Cardinality. This could also be represented by letter N, small letter n. So cardinality means the number of elements in that particular set. If you have to find the cardinality of set A, assuming A has 1, 2, 3, and 4. So the element we have in A altogether is 4. So the cardinality will then be 4. Now, for example, under the example column we have 3 and 4. Based on that, the cardinality of elements in that particular set is what? 3 and 4, which the cardinality will give us 2. Now we have a sign which is called such as or 2 column. So those one I just used to list out elements in a particular set. Now let me briefly explain this, though it's not required for this particular class. However, you just need to take note of them. Now these are the signs that are used to represent different numbers that we have. N, capital letter N represents natural numbers. Capital letter Z represents integers. While Q, capital letter Q represents rational numbers. A represents algebraic numbers. R represents real numbers. I represents imaginary numbers. While C represents complex numbers. Then this is just a bonus for you. So you can see it's there. It means, now let's just read this question. Because I've talked about union, I've talked about the interset, and talked about complement and the rest. Okay, now consider the counting numbers 1, 2, 3, 4, 5, 6, 7, and 8. 8 and 9 rather. So let A equals to 1, 3, 5, 7, and 9. B equals to 2, 4, 6, and 8. C equals to 3 and 5. D equals to 2, 4, 6, and 8. Now, the first question is, find A union B. What's going to be A union B? Remember, A union B is going to be all the elements in A and B without repetition. Then, using that, we'll have what? A union B will give us 1. We have 1 in A. Though it's not in B, but it's going to be all the elements in A and B. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's the answer for what? A. So it means it's going to be what? 1, 2, 3, 4, 5, 6, 7, 8, and 9. We'll have B. The question B says what? Find A intersect B. A intersects B. So there we have what? The elements that are common to A and B. What we can find in A and B. But based on the question we have, do we have anything that is common to both? Of course, no. So it means there's nothing common to both sets. And our answer will be what? Empty set. Now C says find a complement. Find A complement rather. So A complement means elements that we can find in the universal set but cannot be found in what? Set of A, set A. So now set A are given as 1, 3, 5, 7, and 9. So what are the complements of A, or what are those things that we added to A that will make it a complete universal set? So those ones are what? 2, 4, 6, and 8. And the last one, we have to find what? B intersect C. B intersect C. So meaning that what elements that are common to B and C, sets B and C. So look at B and look at C. Do we have anything that is common to both? Of course, no, we don't have anything that is common to what? B intersect C. We have 2, 4, 6, and 8 in B, and we have 3 and 5 only in C. So that's it. Now we're going to talk about Venn diagram. As you can see, it's there. Now, when we talk about Venn diagram generally, what you need to do is that. So it means we make use of what shapes to explain this aspect of sets. So that's when we use what we call Venn diagram. We're still on that. Now let me briefly explain these two-dimensional sets. So the first one we'll have there is what? A complement. Now every other thing, you can see we have circle A and circle B, though B is not written. So the circle there is called what? A complement. The white spot is what represents A. Every other thing outside that circle of A, where we have the white circle, so represents the complement of A. Now moving back to the second one. So we have A union B. A union B simply means what? All the elements that can be found in A and B, and also that can be found in both. So we'll talk about A intersection B. You can see the red shade, the area shaded with red ink. So that one means what? The thing that is common to what? Both A and B. So from there we move to B minus A. B minus A. Meaning that elements that can be found in B but are not found in what? A. Elements that can be found in B but are not found in A. So we are still moving. Now let's look at this. Now looking at what we have above there, I think this will give us a clear understanding of what we are actually talking about. The first one there represents A. It means all the elements that can be found in A. So what is the second one? You can see every other thing is what shaded except the circle of A. So it means A complement. Every other thing outside the circle of A is what? A complement. Now when we talk about the third rectangle, so we have nothing of them shaded. So it means A and B are disjoint sets, but both of them are what? Subset of the universal set. However, nothing is common to A and B. And the last one, we can see B written inside A. It means B is proper subset of A. All the elements I mentioned again, all the elements in B can be found in what? A and A has more elements which are not listed in B. So now, we'll come to the end of today's class, and in our next class, we'll continue right from here. I will treat questions on 3-dimensional sets and also 4-dimensional sets using Venn diagram. Thank you very much for your time. So we'll come to today's class. Bye for now.